Hey guys, today we're going to do the last section of Chapter 7, Section 4, Differential Equations, Growth and Decay. So the law of exponential change, y equals ce to the kt, is the equation that we're going to use for that. And I've given you a little bit of kind of review information here that you may need to be able to do problem number 1. So u prime over u, 1 over u du is, and the antiderivative is ln absolute value of u plus c. E to the x is y is the same as ln absolute value of y equals x. Exponent rules, b to the m plus n is b to the m times b to the n, and e to the c will be your constant c, and that's going to come up here in just a minute. So dy dt equals ky. We're going to start by saying dy over y equals k dt. Remember, k is going to be like our number, our constant. So ln absolute value of y is equal to kt plus c. And so when y is inside of our ln, we are going to make both sides become the power of e. So that's going to drop our y down. Y equals e to the kt plus c. And as we talked about here, we've got our exponent rules and our constant rule for e to the c. This is going to be e to the kt times e to the c, which is ce to the kt. Now, example 1 is just the proof of why it is what it is. What we're going to do on the next page is use that formula. So for example 2, the rate of change of y is proportional to y. When t is equal to 0, y is equal to 3, and when t is equal to 2, y is equal to 6. What is the value of y when t is equal to 3? So a couple of things to note. dy dt is ky, which we know is y equals ce to the kt. We know that t is 0 when y is 3, and that is initially because t is 0. And then we're going to start into our problem. So we're going to start with y equals ce to the kt, 0, 3. So 3 equals ce to the 0 k. So c is equal to 3. Then we're going to use t equals 2 and y equals 6. Y equals c is 3. So 6 equals 3e to the 2k. 2 is equal to e to the 2k. So ln2 equals 2k ln e, ln on both sides to solve for k. So ln2 divided by 2 is approximately 0.3466. Now, 1/2 ln2 is the same as ln of 2 to the 1/2, which is ln square root of 2. We're going to use that here in just a second, because that is an approximation, and we do not want an approximation yet in our problem. So now we're going to look at the model, the equation. Y equals 3e to the ln square root of 2 times t. And we're going to say when t is 3, what is y? So y equals 3e to the ln square root of 2 times 3. Using your calculator, you should get 8.48595. To show this on a graph, and if you were to graph your function, the point 0.03 and the point 38.486, on your calculator would show your growth function. Example 3. The number of bacteria in a culture is growing at a rate of 3,000 e to the 2t over 5 power per unit of time t. At t equals 0, the number of bacteria present was 7,500. Find the number present at t equals 5. So the rate dB dt equals 3,000 e to 2t over 5. Antiderivative separate your variables. Antiderivative times the derivative here. And then that's 7,500 e to the 2t over 5. We're just going to say that's b of t so that we can say find b of 5. Plugging that into your calculator gives you approximately 55,418 bacteria. And again, we knew that at time t equals 0, our number was 7,500, and we knew that we were using CE to the KT. All right, taking a look at number 4. A slow economy caused a company's annual revenues to drop from 530,000 in 2008 to 386,000 in 2010. If the revenue is following an exponential pattern of decline, what is the expected revenue for 2013? Feel free to pause your video and try it if you'd like. So we know our model is y equals CE to the KT. And in this problem, we know that we are given in the year 0 when we started, we had 530,000. And then 2 years later, we dropped to 386,000. And we know C is our initial amount at 530,000. So next we're going to find K. So Y, we'll say 386,000 equals C, 530,000, E to the 2K. So 386 over 530 equals E to the 2K. So ln on both sides. Equals 2K ln E. Divide by 2, and K is approximately negative 0.15852. So when T is 5, what is Y? Now where did that 5 come from? 2013 is 5 years after 2008. So we're going to use our model to solve. Y equals 530,000 e to negative 0.15852t. Y of 5, plugging in 5 for t, is approximately $239,913.16. And this is the expected revenue for 2013. Suppose a population of insects increases according to the law of exponential growth. There were 130 insects after the 3rd day of the experiment and 380 after the 7th day. Approximately how many insects were in the initial population? So Y equals CE to the KT. Our points are 3, 130, and 7, 380. So we know that this is 130 equals CE to the 3K, and this one is 380 equals CE to the 7K. So we're going to solve for C and then substitute to find K. So 130 equals CE to the 3K. 130 divided by E to the 3K equals C. So C equals 130 E to the negative 3K. And 380 equals CE to the 7K. Substituting that value for C. When you multiply, add the exponents. Ln on both sides. And K is approximately 0.268159. Again, guys, use those calculators to check those numbers so that when you're doing these on your own, you know exactly what buttons you need to push. Growth model. Y equals CE to the 1/4 ln 38 over 13t. I'm just using the exact numbers here. 38 over 13, 1/4, divide by 4. So they're exact. And then when t equals 3, so we have 130 equals CE to the 0.268159 times 3. And C would give me approximately 58 insects initially. All right, half-life. I have a formula up here at the top for you to see. We're going to use the same C equals KT. Remember, when it gives you 4,000, half of that would end up being 2,000. So that's part of what half-life is all about, is being able to set up that model. So we have Y equals CE to the KT. So 2,000 equals 4,000 E. A zircon sample contains 4,000 atoms of the radioactive element 235U. Given that 235U has a half-life of 700 million years, how long would it take to decay to 125 atoms? So 1/2 equals E to the 700K, ln on both sides. And K is negative 0.00099021025.8. So solve. 125 equals 4,000 E to the negative, this negative, ln 1/2 divided by 700. That's what that value is there. So 125 divided by 4,000. So ln on both sides. And then that's going to drop down. So I'm going to go ahead and divide by that. and you should get 3,500 million years before zircon degrades to 125 atoms. Quite a long time. A cup of hot chocolate placed on a table cools at a rate of dHdt equals negative 0.05 times H minus 75 degrees Fahrenheit per minute, where H represents the temperature of the hot chocolate and T is time in minutes. If the coffee was at 160 degrees Fahrenheit initially, what will its temperature be 10 minutes later? So we're cooling. So we're going to use C here. So the temperature we're cooling is negative 0.05 times C minus 75. So we have dC over C minus 75 equals negative 0.05 dt. Antiderivatives, ln, excuse me, absolute value C minus 75 equals negative 0.05 t plus C. Both sides become the power of E to get that C out of the ln. C minus 75 equals E to the negative 0.05 t plus C. And then C of t would be 75 plus E to the negative 0.05 t. And we're going to bring that C down front. And because we're in a C of t function and C is here as well, let's change that to K. So C of 0 we said was 160. So C of t is equal to, did we find C? E of C is equal to K. So looks like C is going to be 85. So 75 plus 85 e to the negative 0.05 t. So C of 10 is approximately 127 degrees Fahrenheit. All right, guys, this concludes chapter 7. You guys let me know if you have any questions, and I hope you have a great day.